at products of polynomials. So let's first start with a simple case that is a binomial times a binomial, and we'll write about the simplest binomials that we can. X plus 3 times x plus 2. So we know from our rules about the distributive property that we need to take the first term in the first factor times both terms in the second factor, and then we will need to take the second term in the first factor times both terms in the second factor. Sometimes you may have heard this called the FOIL method, because when we multiply the first times the first, we'll call that F. When we multiply the first times the last, we could call those the outer terms for I. So we get an I there. And then the next thing that we did was we multiplied the inner terms, and then we multiplied both of the last terms together and created a FOIL in doing that. What the FOIL method really says is that when you have two binomials, you take every term in the first factor times every term in the second factor. So if we have a 2 terms by 2 terms, this should give us a total of 4 terms of product. So let's go ahead and do that. So when we multiply the first term times the first term, we get x squared. When we multiply the x in the first factor times the 2 in the second factor, we get plus 2x. And then when we do the inner terms, we have the 3 from the first factor times the x of the second factor, and we get 3x. And then when we take 3 times 2, we get 6. Now, in looking at this, you probably realize this simplifies. So we do, in fact, get 4 products when we have a 2 terms by 2 terms, a binomial times a binomial. But in many cases, the products will reduce, will be able to be added together, and so we can get a simplified expression which doesn't have as many terms as we had products. So we end up with x squared, and then 2x plus 3x gives us 5x, and then we add on the 6. So the simplest version of the product would be x squared plus 5x plus 6 in descending order. Now we could visualize this whole thing as having been, if we look at the first factor of x plus 3, we could think of the green line here as being x. And then we need to add on plus 3 to it. So I'm going to add on in purple plus 3. So in green we had x. And then the second factor had an x, but then it only had a plus 2. Now we don't know if x is bigger than 2 or 3, but I'm pretending it is for this argument, and so we have a plus 2 right here. And then if we were going to construct the product of the sides, we would have to create these various pieces of the rectangle. And obviously mine's not to scale because x by x should be a square, but when we multiply those parts together, we should get a size of x squared. When we multiply the 3 times the x, we should get a 3x. When we multiply 2 and x, we should get a 2x. And then when we multiply the 2 times the 3, we get a 6. So if you had a side that is x plus 3 and another side that is x plus 2, and you multiply them together, you in fact get the 4 products that we just talked about, x squared plus 2x plus 3x plus 6, and the 3x and the 2x can be combined to give you 5x, as in the example. Now what would happen if I had 3 factors? So let's consider the case 3 times x plus 3 times x plus 2. Well, there are a lot of ways that we could handle this using the commutative and associative properties of multiplication. I could multiply the 3 times the quantity x plus 3. I could multiply the 3 times the x plus 2 first, or I could first multiply the x plus 3 times the x plus 2. Since we've already done the last of those options, let's just finish by using that. Let's say, since we know that the quantity x plus 3 times the quantity x plus 2 is x squared plus 5x plus 6, 3 times that quantity would be the simplified version of our expression when we fully expand it. So we could now multiply 3 times every term in the second factor. We now have 3 times one factor. And so we can multiply 3 times each of the terms in that factor and get a 3x squared plus 15x plus 18. I'm just showing the lines in pink. Typically, those don't get drawn in, but if they help you, go ahead and make them lightly on your page. Now let's consider another example. Let's consider the example that's just slightly more complicated. It's once again a 2 by 2. It's a binomial times a binomial. But the first binomial has an exponent of 2 on the first term. So what would we do? We would follow the same pattern that we had before. We take the first term of the first factor and multiply it by both other factors, which would give us, when we do the first multiplication, 2x squared times x is 2x cubed. 2x squared times negative 1 gives me minus 2x squared. And then we have to take the 3 times the x, so that gives us plus 3x, and then the 3 times a negative 1 gives me minus 3. All right, now when we look at this, we can see we do not have any terms that are like each other. We have a cubic term, a squared term, a term to the first power, often called a linear term, and a constant term. None of those are like each other, so in this case, the 2 by 2, a binomial times a binomial, does in fact give us 4 terms in our final answer because nothing can be added together. Let's look at one final case. Let's look at a binomial times a trinomial. So in this case, let's use a simple binomial, x minus 1, times a trinomial, 5x squared plus 3x minus 1. So just quickly, we've got 2 terms times 3 terms. So when we do the product, we should get 6 terms that we write out. So let me just clear that out of the way. And let's begin considering all of the combinations of things that we need to multiply. So first of all, we could multiply the x times the 5x squared, and we would end up with a 5x cubed when we do that. Then we have to take x times 3x, and that gives us plus 3x squared. And then we have to do multiply x times negative 1, and that gives us minus x. Now we need to turn around and take the negative 1. Be careful here because this is because of the negative sign here. It's negative 1 times each of the terms in the second factor. So we get minus 5x squared. I'm writing it in a second line because I'll run out of room if I don't. And negative 1 times 3x gives us minus 3x. And negative 1 times negative 1 gives me a plus 1. Now we can do some simplification by adding things. You'll notice that we have, hopefully you notice, that we have 2 terms that have x squares in them and 2 terms that have x's in them. So while we have 6 products, because we had a 2 by 3, two terms by 3 terms in the multiplication, 2 of those will reduce down. So the final answer will have a 5x cubed, but we have a positive 3x squared term and a minus 5x squared term, so that's minus 2x squares. And then we have a minus x and a minus 3x term, and so those will combine to give us a negative 4x term, and then we have to add on 1. So our final answer, when we expand the polynomial and combine like terms, is 5x cubed minus 2x squared minus 4x plus 1. Remember, the key to all of this is take every term in the first factor times every term in the second factor when you do the multiplication. And if you have more than 2 factors, just do the multiplication 2 factors at a time, and then keep on going.